Hello, welcome back. In this video, we are going to see how to create the project for the radiometric data analysis, and also how to import our grids, and also how we export them to Google Earth to see that the study area is actually on the grid that we have. We'll start with the radiometrics because we already have our data, and because if we check again, okay, first let's just open your IS montage. Then we'll click on File, Project, then New. Then we'll scroll back to the desktop for our main work under the radiometric. Then under this we'll call radiometric project. That's the name of the project. Click Save. Then we allow it to run. So I think this is what we have under radiometrics. We are familiar with, to click on click, right click, add grids. We have our data, we have the 3 grids, so we have to bring this potassium first. So this is a potassium. All we need for the potassium, you can see, is in the projected coordinate system. We'll go to coordinates, it is unknown. Go to grid and image utilities, save grid to database. The channel, the grid name is this. The new database is, you can see the sheet is 104 potassium, which I call 104 potassium. This is not the study area. Then the channel is Z. Then OK. This is what we have. Then we'll go back to this grid, right click, remove. Then this is the grid. We need to go to coordinate system, set the coordinate system first, because if you check the database, click on it, right click, properties is not set. So we need to go to coordinate system, ability set, then projected. Then we need to check your projection datum. Here is around UTM 32. This is part of Nigeria, so look for your country, which is 32 degree north. You can see this is what we have. Then okay, now it's been projected correctly. Then right click, properties. You can see this is what we have. Now we'll go back to the other one. Data will come to the thorium, the same thing. Utilities, save grid to database. Now we scroll for this. Then this is thorium. You can see this thorium, which I call T, capital TH. Then OK. Then this, right click, remove. Then this database is selected because it's bold. Then coordinate system. Select this. This is unknown. They'll click on projected. This is 32, and that's what we have. And now if we right click, properties, we'll see it. That's what we have. Then the next thing, we'll import the last grid, which is under the database, uranium. The same process, utilities, save grid to database. Now this is uranium. I will call it U. We'll cross check, is uranium, yes, 104, then OK. I will come here, right click, this. The uranium, you see, is not yet projected, it's unknown. Okay, so selected, there we'll go to coordinate system. Then set projected, it's been set. Now we'll go back to potassium. Now we need to project this to longitude and latitude. Then right click here, say insert column, click, right click, insert column, click, right click, new, long, click, long. We have new, they'll call it lat. Then all we need to do now is to try to project and coordinate new projected coordinate system. Click next. Okay, it's already there. The next now is to project it from X to longitude, Y to latitude. The next, now we set geographic coordinate system. All this is going to be populated. So you can see, this is the form of degree, minute, and seconds. You can leave this format, or if you like, right click, edit, change this to normal, 4 place of decimal, right click, edit, geographic, normal, 4 places of decimal. So this is what we have. Now we need to switch this coordinate from x to longitude, y to latitude. Go to coordinates, set coordinates. X now is long, y is lat. The third value is z, which is okay. Now we need to create our grading, minimum curvature. Now the channel to grade is z. The output grade is 104 potassium. Okay. This is potassium for the whole grade. We have okay. So we're going to produce the grade we have. So this is a potassium. We have, then we'll do now for the thorium, the same thing for thorium. Then right click, the same process. Call it long. Click this is what we have. New, then lat. So this one is not there. We need to delete this. Height column. Okay. Then let's project it. Just like before. Go click OK. Then now everything is set. Just click OK. Then geographic. Now it's there. We click on this 3 dots to show the other value. Click edit. Geographic changes to 4. Click OK. Click edit. Changes to normal. Then 4 place of decimal. Then now switch the coordinates. Longitude, this is lat, then okay. Then now we grade for the thorium. Then the channel is Z. Now this one we call it 104 thorium. We'll leave it empty like this. See all the same. 104, then will remain the uranium. Look at the database. There we say click insert column, click insert column, then click new long, then click lat. There we need to set a projected coordinate system now to geographic. This one is to set the initial is projected XY, and now we now change X to longitude, Y to latitude. Next, they'll give it geographic. We are now converting. We'll move this one, then click edit. Change the format to normal, then give it 4 place of decimal or 5 or any one you need to use. Does not matter. It's just for display purpose. The next is to swap this coordinate, X now to become longitude and Y to become latitude by going to coordinate, set coordinate. This is long, this is lat, then okay. Now we need to grade this one with minimum curvature. This we call it 104, then we'll call it uranium. If it is okay. Now we have our 3 grades, 1 uranium, thorium, and what? Potassium. You can see the concentration of potassium, the equivalent concentration of thorium, and that of uranium. Now let's take the thorium, which is geographic, which you can see. They'll click on this map mode. They will click on the grid. We want to take it to Google Earth so that we can see it clearly. When it's selected, then go to map, export, and I'll change this one to GeoTIFF. You can see it. Then click full map, set the screen, change this resolution to 100 so that we have 4 megabytes. GeoTIFF full map. Okay, put the screen dot. You see, this is the size, estimated size, full map. This, then click OK. Go back to your main folder, raster images. This is called 104 potassium. That is a tape we have. So this is for us to see whether the study area is on these radiometrics. Save. Then click on this plus. Then we are good to go. Now let's minimize. Let's open Google Earth. Then go to File, Open. Click on this file type to GeoTIFF. And now go to your project folder, raster images. Click this, then open. You can see it's coming now. Then you bring down the resolution down to around this point. This is what you have. Like this is okay, so you can see clearly, or you can break it down anywhere you want it. Let me leave it like this. It's okay. So now you can see it. This is within the study area. I can bring my towns. You see them. My mining point is within. This is how I'm able to get the study area of my area. You bring the grid and then you locate the mining point within that grid. So this is the part of the grid that I need to use. All these other ones are the same thing you get. So our study area now is within the grid. So this is how to create a project, how to import the grids, and how to confirm that our study area is actually on the grids. So the radiometric grid we're going to do our analysis is fall within. As we can see, it falls within from the right down to somewhere here, and that is all what we have.